as time passes, maybe after some 10 minutes, 15 minutes, sometime they may lose interest in giving you the
We are extremely sorry for the inconvenience. Sir is having some technical issues. Sir will rejoin the meeting in another 2 to 3 minutes. We are extremely sorry for the inconvenience. Inconvenience caused, deeply regretted.
Yeah, I'm sorry, I lost connectivity. I mean, sorry. Yeah. Yeah, as I already told, let me give a very brief things about actually in data analysis. Most important thing is you have to, first of all, you have to prepare the schedule or questionnaire strictly based on your objectives of the study, and again after preparing this schedule, you should create the master data sheet nicely. You can create a master data sheet either in Excel or in SPSS. This is actually, the master data sheet is one of the most important instrument which is being widely highly useful for a researcher to analyze the data and to draw the inference. And if you are going to do any mistake in it, definitely if you miss some important data, you will be in trouble. If your schedule is too lengthy and if you are collecting too much of data which is not actually required, then it will suffer from the quality. So therefore, let me take some 10 to 15 minutes regarding this two important things about
Sir,
this.
would you be sharing your screen, sir? Would you be sharing your screen, sir?
Yeah, actually I'm sharing. No, I just.
No, sir. No, sir. It is not visible, sir.
Okay, 1 second.
Yes, sir.
I think now it is visible. Okay.
Yeah, now it is visible, sir. Thank you, sir.
Okay. 1 second. I'm sorry. Yeah, I'm going to speak on three important things. One is master data sheet. This master data sheet is the one which contains the consolidated data required for the entire research process. In fact, it is the base. It is the base. And while creating this master data sheet, in the primary, I mean, any research which is based on the primary data, you have to use the fully, schedule or questionnaire. In fact, are the basic source of data of any research for that matter. And based on that schedule and questionnaire, you are preparing that master data sheet. And this master data sheet is the, creation of master data sheet.
Sir, please unmute yourself, sir.
Automatically, yeah. Now, audible now?
Yes, sir, you're audible, sir.
Yeah, right. Yeah. I was here. Yeah. In the any research based on this primary data, actually schedule or questionnaire are the basic source of data. And by using that, you have to create the master data. You have to create a master data sheet. In fact, it is the process of transferring your data from schedule or questionnaire to consolidated data sheet. And in fact, after this, particularly for the last 2 to 3 decades, this data management become very comfortable for particularly to you, the young scholars. Probably you may feel much comfortable in managing the data with this Excel or SPSS, whatever. So I'm not going to speak much on SPSS. I'm just using this simple. I'm going to just take some 10 minutes, which is something most important in data analysis. And just let me give some important information or guidelines to construct the master data sheet, whether you are creating it in SPSS or in Excel. And variables should be precisely specified with the appropriate abbreviations. In fact, I've seen many scholars where who did a lot of mistake in doing it. And coding should be logical, and even sometimes people used to create, they code properly, but sometimes they maintain, they fail to maintain some record. Sometimes they may forget, what code in some particular variable, what is the meaning of this one? What is the meaning of this two? Like that. See, you should give, coding should be logical. Say, for example, while you want to give coding for, say, for land holding size, you can give, that must be sequential. For landless, you can give 0, or for marginal farmers, you can give 1. And for small farmers, you can give 3. Like that, like that, you have to give the coding. And you should have the coding, you should have that coding sheet, which will have the meaning of the different codes, what meaning that different code stands for. And, this even while preparing the schedule, see, prepare the schedule or questionnaire strictly based on the objectives of your study. And you have to thoroughly understand the objectives of your study. And you have to dissect what this objective is, what this objective is expecting from me, and what are the functional variables that I could use here. Like that you have to do. And make it as, your schedule or questionnaire should be as short as possible. And it should be long enough to get the data essential to meet the objectives of your study. This is very, very important for a researcher. In the sense, if you make it too lengthy, the respondent may not give you good quality data. If it is too short, sometimes if you, by making, in the process of making it as short as possible, if you miss some of the important variables, it may put you in trouble. So collect only the data, the information which you cannot obtain from secondary sources. Whatever data is available from secondary sources, use it. You have to make use of it. And it should not contain questions which are behind the memory span of the respondents. Sometimes, many times I used to ask researcher, yes, yeah, I do accept. You have collected the data from respondent, but is it reliable? Say, just simple thing is, you may ask a respondent about annual income. How many people are able to give the accurate data on annual income? Is it dependable? So like that, you have to analyze and you have to make, see, that is the reason why actually earlier most of the economists and geographers were using annual income of the family. But now people are shifting towards asset position, asset index or something. People are using asset index and other things to analyze the economic status of the household, because sometimes people may not able to give you the accurate data. Like this you have to do. These are some of the important things that you should keep in your mind while preparing the schedule, and properly understand the data requirement. See, just let me give a very simple example. Let me take 5 minutes to understand how to understand your data requirement. I have taken a very simple example. Probably there may be, I'm sure that there are faculties from different disciplines. There are faculties from many. Say, I prepare the examples in such a way that they must be easily understandable to all these scholars. Of course, this particular example I prepared for some earlier lecture. See, let us take that there is one study which analyzed the impact of economic reforms on socio-economic conditions of rural households. And in fact, this kind of study is common with sociology, economics, political science, and other things. See, let us say that the objectives of this study is to analyze the impact of economic reforms on social change at rural family level, and to analyze the impact of economic reforms on economic conditions of the rural households. So let us say that these are the objectives. Based on these objectives, you have to prepare some operational definitions of social. For example, I used the word social change. See, sometimes even earlier I used the words, operational definitions. So operational definition in the sense, sometimes we use the concept. We use a concept, and you have to convert that concept into operational definition. Operational variables. See, any concept or any variable you have to use it operational, and that must be, you must be able to collect some quantitative or qualitative data from the respondents to analyze it. You have to make it operational. So, for example, here is I used the word social change. Social change, operational definition of social change at family level, we can use, for example, change in family system. Family system means, we used to say earlier people were in joint family. Now people are shifting more and more towards nuclear family. So this is a kind of thing, or operational definition we could bring down from some basic concept to some operational variable or operational definition. And is there any improvement in economic condition? How do you analyze economic condition? There are many ways to analyze change in economic condition. Is there any improvement in the housing condition? Is there improvement in the capital asset of the family? Is there any improvement in the consumer durables that family is using? Like that, you have to dissect and you have to define, you have to identify operational definition and operational variables about which you can collect the data. And after this, see, even while doing it, you have to prepare a dummy table. See, most of the social science scholars, even for my scholars, I'm not sending them for collecting the data without they're preparing the dummy table. I push a lot of this concept about dummy table. See, dummy table are the tables without the data or the result. You will be able to prepare the tables for your thesis or any research report only after collecting the data. But yeah, by properly analyzing the objectives of your study and the conceptual framework of your study, you can visualize. Yeah, this is the thing that I want to put. See, I can analyze it by preparing the table of this kind in my thesis or in my research report. Like that, you have to prepare the dummy table. In fact, this dummy table or the tables are the format in which data or result have to be filled after collection, after analysis of the data. And preparation of dummy table helps the researcher for many things. Most importantly, it limits the schedule or questionnaire to the data essential for the study. Most important thing. And schedules or questionnaires will not miss the necessary data. And also in that process, we will be able to, what is for your core objective, what are the most important variables and about which I must be very careful. You'll be able to understand what kind of data is very important. So like that, and schedule and questionnaire will not contain the unnecessary data. So therefore, dummy table helps in attaining the, I used to tell you that dummy table will help you in attaining the following strategy. Schedule or questionnaire should be prepared in such a way that it should not bore the respondents. It should not bore the respondent who is providing you data. And at the same time, it should not miss the necessary information. So this should be your objective. They're just, see, dummy table. I told I just prepared some captions. I mean, column headings, row headings like this. These are the dummy tables. And you see, this way we have to prepare the dummy tables. And if you take this is the schedule. Based on this schedule, you have to create the master data sheet like this. Even of course, I have prepared some other code sheet. Of course, it is missing here. I wanted to show you, because most of the in my experience, scholars used to come and, sir, I have collected data.
Oh,
Yeah. This is the master data table that I prepared in Excel for this schedule that I have shown. I have taken both the things. I prepared both the things. See, this is the Excel worksheet I prepared in Excel sheet, and this is the one, the schedule that I use. So these are some of the basic things. So with this strategy, see, so actually now with these basic things about the data management, then let me come to my core aspect, that is about statistical inference. As I already told you earlier, see, drawing inference is very, very important. In fact, it is based on the way how you draw the inference. You are you are writing the findings of your thesis, and in fact, usually the findings of your research is important. The soul of your thesis. Actually, nobody will ask you about how did you do your research. In fact, most of the times, if you do some useful research, people will ask you, what are your findings? See, so therefore, the findings are very, very important part of your thesis. But how do you say that it is your finding? Your finding must be scientific. You could say that your finding is scientific if you draw the inference based on scientific principle. So therefore, statistical inference focus on using the probability principle or using other statistical techniques to draw scientific and valid conclusions or inference. So therefore, here statistical inference, in fact, they refers to draw conclusions about the population by using the inferential statistical technique. That is one thing. Actually, we draw the inferential statistic. We draw the inference based on by using the inferential statistical techniques. Again, when we speak of inferential statistical techniques, it includes tests. You are using probability distributions, the probability principles. Actually, Suchitra madam is going to speak on the theoretical distributions or probability distributions, which is very, very important for in fact, it will be a base.
Sorry, sir. Are you changing the slides or are you still in the second slide, sir?
Yeah, I am in the first slide only, statistical inference in first slide only, Chetan. Yeah.
Okay, sir. And did you actually open the Excel sheet, sir?
Not yet. I have not opened
yet. Okay, fine, sir. Fine, sir.
Yeah. We in statistical inference, it refers to draw conclusion about population by using the inferential statistical techniques. And in fact, inferential statistical techniques are the techniques which we are using to draw the conclusion about population. And we see in this analysis, our focus is on population. We have to draw inference, we have to draw conclusions about the population. For that, we are using the sample statistics. Like, if we are, say, for example, blood test. See, whenever you are giving the blood test, you give some 4-5 ml or maybe 2-3 ml of blood. See, by using that, by analyzing the 2-3 ml of blood, the inference is being drawn about the blood of your entire body. See, the 5 to 6 liters of blood in your body is the population for us. And the sample 2-3 ml of blood is the sample. Based on that sample, doctor or the people, they are going to draw conclusion about the blood of the entire population. So that is, our focus is on drawing conclusions about population based on the sample statistics. Sample statistics is some statistics which is calculated for the sample data we have. So here, in fact, statistical inference aims at understanding the characteristics of population from a sample statistics, as I already mentioned. See, the population characteristics are the parameters. and sample characteristics are the statistics. You see, these two things. I have seen most of the things who are not good at statistics. Most of the times they get confused with the statistics and parameters. Parameter is the population characteristics. Statistics is the characteristics. I mean, some value calculated for the sample data. So by using the sample statistics, we draw conclusions about the parameter. And again, in this process, in research, we use three. I mean, whenever we are using the inference, statistical inference, we use three important things. One is estimation. Another one is testing hypothesis. Estimation, again, it involves sometimes we may go for point estimation. Some other times we may go for interval estimation. And actually, most of the times, actually, these estimation questions come only when you want to estimate and forecast something. Actually, the researchers in economics, they quite often use the point estimation and interval estimation. But in other social science, like, whether it may be sociology, political science, in most of the other science, other social sciences, by and large, we focus more on testing the hypothesis. So therefore, I will be very brief about this point estimation and interval estimation, but I will be a bit elaborate on hypothesis testing. First, let me give you some hints about the concept of point estimation and interval estimation. After that, we could go for hypothesis testing. See here, hypothesis testing is many times we may calculate some sample statistics. How far that sample statistics is the true characteristics of the population, whether a particular sample value is it really the real characteristics of the population, or some value is randomly, whether that value is having some randomness. But many times we may get some result by random, by chance. We may get some result by chance. Whether we get a particular result by chance or it is real, that we are going to analyze it or test it by using the hypothesis testing. Whereas in case of estimation, as far as point estimation, in case of point estimation, our focus is on estimating a single value about a particular population. Whereas interval estimation, we sometimes, you may have seen, sometimes you may guess. While you are guessing the age of your friend or weight of your friend, you may say, yeah, I feel, or I can estimate, by looking at you, I can say that your weight may be some 70 kg. If you say that, you are estimating it, your estimation is point estimation. Looking at your friend, if you say that, oh, your weight will be 70 kg, you are estimating that his weight is 70 kg. It is a single value. It is a point estimation. If you are estimating that, oh, looking at you, I can say that your weight will be somewhere between 65 to 75 kg. It is an interval estimation. So this is the difference between point estimation and the interval estimation. See here, actually, in economics, you may find that most of the times we use the interval estimation. Actually, what are the most important component of interval estimation? You see, here is a very simple formula. I think it is visible to you. I think, is it visible? Here is
no, sir, it's not visible, sir.
It is not visible?
Are you changing the slides, sir?
Now, Chetan, I am in 3x3 slide.
3x3, no, sir. The slides haven't moved, sir.
Actually, I am in 3x3 slide now.
But we are seeing that hyperlink.
No. Actually, what should I do?
Sir, again, share your screen, sir. 1 second, sir. This will stop the others.
Yeah, let me do one thing. Stop share, and then again I will share you. Okay.
Yes, sir. Yes, sir.
This I think good. Let me share it again. Is it visible now?
Now it is visible, sir.
Which is
that formula is there, sir. Components of confidence interval.
Yeah. It is there. No, the most important component of this interval estimation is X bar is there. It is sample statistics. It is nothing but arithmetic mean. Plus or minus. There is one value. There is a T. T means you might have seen T value. Table value of T. So whenever you are using the confidence level. See, if you want to test it at 5% level, we are using the concept of testing it at 5% level, 1% probability level. I'm going to speak you about short while. I mean, after short time. I mean, after short while, I'm going to speak you about this kind of things. I'm going to give you details about this probability level. Yeah, I'm going to speak on that. Say t value, it is a table value of t at a specified level of significance. Significance, I'm going to speak about, I mean, I'm going to tell you about that theoretical distribution and other things. After that, it will be useful. We'll right now take this thing as t means it is table value of t. And the sigma over root n, it is actually standard error. First thing is sample statistics, plus or minus, maybe less or maybe plus t value, table value of t, and the rest of the thing is standard error. These are the three important components in the interval estimation. By using this interval estimation, we could go for this. We could go for this. What you can say interval estimation. Chetan, now is it the impact of IPM technology on cotton?
Yes, sir. Yes, sir. Yeah. Yes, sir. Now the slides are moving, sir.
Yeah. Let me take some very simple example to enable you to understand this point estimation and also interval estimation. Let me explain you about this point estimation and interval estimation with some practical example. I have one example here. This study is relating to impact of IPM technology on cotton productivity. In fact, this is the research I did when I was in Agriculture University, Agriculture College, Raichur. But I've taken some glimpse of that to show you. See, to actually and deliberately I've taken this example, the productivity, yield, agriculture. I think it is easily understandable to all the participants from all the disciplines, whether it may be from different, like history or economics or political science. For that reason, I've taken this example. See, the objective of the study is to estimate the cotton yield obtained by the farmers who have adopted the IPM technology. See, IPM means integrated pest management technology. It is a technological component. Even if you are not able to understand this core aspect of this IPM technology, don't worry. This is a kind of technology. This technology I like. See, a farmer has to use all integrated pest management technology. Like they have to use seed treatment. They have to go for selecting the right pesticide, and they have to go for cold crushing and other things. This is the technology. If the farmer, the objective of the study is to estimate the cotton yield obtained by the farmers who have adopted the IPM technology. See, here we have to compare. We have to identify the farmers who have adopted the IPM technology and who have not adopted the IPM technology. And see, to analyze the impact of IPM integrated pest management on cotton yield, we have to compare the cotton yield obtained by the farmers who have adopted this IPM compared to the farmers who have not adopted this IPM technology. See, here I have written the concept HA. I hope all of you are familiar with the concept of HA. HA means it is alternative hypothesis or research hypothesis, I can say. Actually, we begin our research with research hypothesis, not with null hypothesis. Many a times people used to get confused. What is this null hypothesis and alternative hypothesis? In fact, you always, even in the very beginning, in your mind, you begin a research problem with some doubt in your mind. In fact, that happens to be your research hypothesis. Research hypothesis subsequently we use it as an alternative hypothesis. See, here in this context, research hypothesis is cotton yield obtained by the farmers who have adopted the IPM is significantly more compared to the farmers who have not adopted this technology. So this is the thing. I hope these things are very clear, simple, and this is the alternative. And if to test this, you can have the null hypothesis. Null hypothesis is cotton yield obtained by the farmers who have adopted IPM is not different from that of the people who have not adopted. That's it. Only thing, there is significant difference. In null hypothesis, we used to say there is no difference. There is significant difference and there is no difference. These are the things we could find in alternative and null hypothesis. With this, let me go to next slide. I hope this slide, Excel slide is visible here, Chetan?
Yes, sir, it is visible, sir.
Yeah. See, you could observe here. I've taken 24 farmers. I've taken the data of 24 farmers. Farmers 1, 2, 3, and so on up to 24 farmer. Here I've given the farmer number 1 who has obtained. This is the group of farmers who have adopted this IPM, because I have written CY, cotton yield obtained by IPM farmers. 10 quintals. Erane farmer, second farmer, he may be Manjana or somebody, or John, he obtained 12 quintals. And third farmer is, say, Mr. Philip, you obtained 15 quintals of cotton. Like that, different, this number they represent different farmers obtain different cotton yield. See here at the bottom, I think 14.92, it is visible here, 14.92. 14.92 is nothing but arithmetic mean. See in Excel, putting the cursor here, if you write equals and average, A-V-E-R-A-G-E, average, open the bracket and select the data from B2 to B25 and give enter, you will get the arithmetic mean value here. In fact, some of the scholar may be better than the, I mean, you may feel it much easier. Yeah, some there you may, I find good number of scholars who are finding it difficult to hear such things, small things also. So this is the arithmetic. 14.92 is arithmetic mean. Earlier I showed, no, this is arithmetic mean, and this 2.225 is standard deviation. So for this sample, I have calculated the standard, I mean, arithmetic mean, and this. See, this arithmetic mean is nothing but the point estimation. So that means the sample farmers have obtained average yield of 14.92. This is a point estimation. So this group of farmers who have adopted this IPM technology, they have obtained cotton yield of 14.92 quintal. So this is a point estimation. So this is here the arithmetic mean, the statistics, it is a estimator. The statistics is, this is an estimator which estimate a particular value for this particular group of sample. So this is a point estimator. So then let me go to next slide. I hope this slide is visible here. So I just extended. I wanted to give some interval estimation for the same example. Chetan, is it visible here?
Yes, sir. Yes, sir. It is visible, sir.
I've written something.
Yes, sir. Yes, sir. Yeah. Yes, sir.
Here you could observe. Here what I have taken is, see here the same 14.92 is here. I have taken that formula, x bar plus or minus t sigma over root of n. Things are very clear here. Arithmetic mean, x bar is arithmetic mean. I have taken it as 14.92 plus or minus this t 1.714. It is the table value. It is the table value. This table value means again t value for 23 degrees of freedom. 23 degrees, you see here sample is 24 means n is 24, n minus 1 is 23. This 23 degrees of freedom for 5% level of significance, 5% level of significance, you can find it any statistics books. For 5% significance level for 23 degrees of freedom, table value of t is 1.714. This multiplied by the sigma, standard deviation is 2.25, and root 24 is number of observations, sample size. By simplifying it, we will get, see, plus or minus, see, we will get the range of value 14.14 to 15.698. See, if you ask you, so we have to estimate some interval estimate at 95% level of confidence, that is, I mean to 5% level of significance. Your interval estimate will be 14.142 quintal to 15.698 quintal. That means you are 95% confidence that this population value from which you have selected the sample, this population yield value, population yield will be somewhere between 14.142 quintal to 15.698 quintal. This is the interval estimation. So they sure that 90% of the farmers are expected to get the yield between this 14.142 quintal to 15.698 quintal. This is what the concept of interval estimation is. So I hope I am clear about the concept of this point estimation and interval estimation. So with this basic concept of this point estimation and interval estimation, let me explain you about briefly about this hypothesis testing with one thing, and after that let me go for some systematic with these simple examples. Again, I'm going to tell you about some the sequential things. I mean, systematically, I'm going to put what are the things involved in this hypothesis testing. Here, I have the data set. You could observe there is one column, B column, it indicates cotton yield obtained by 24 farmers who have adopted the integrated pest management technology, IPM technology. And in column C, you could find we have the data from 26 respondents, that is from C2 to C27. This is the cotton yield obtained by different 26 farmers who have not adopted the IPM technology. For these two, actually we want to, for that I know, in the earlier I told you that research hypothesis is the farmers who have adopted the integrated pest management technology, they obtained significantly higher cotton yield compared to the farmers who have not adopted the IPM technology. So that was my research hypothesis. To test it, we have to go for t-test. T-test is the one with the help of which we can draw inference. So with this, see, I have actually this result on the right side, whatever is available here. T-test, 2 sample assuming equivariance. Here you can find B, C, like your result, you get the variable 1, variable 2, mean value, variance, observation, pooled variance, hypothesis. This is all the result estimated by MS Excel software only. And this result is for this data. For this data, I have calculated t-value. T-value is here, t-statistics 5.054 is the calculated t-value, which is intended to test the significance of the difference in the yield, cotton yield, obtained by the group of farmers who have adopted the IPM technology and the group of farmers who have not adopted this IPM technology. Here you could find the farmers who have adopted the IPM technology, average yield of this cotton among the farmers who have adopted this technology was 14.917, and among the farmers who have not adopted it is 11.654 quintal. You can of course visibly find the difference. It is 14.9 quintal, it is 11. Of course, we can, from Outlook itself, we can say that, the farmers who have adopted IPM have obtained more yield compared to the farmers who have not adopted. But is it at what percent of significance we can say, we can draw conclusion that this the adopters have significantly obtained higher crop yield compared to the non-adopters? So for this, we have calculated this t-value. This calculated t-value is 5.054. Critical value is 1.677 for 5% level. So that means calculated value is greater than the table value. So we used to draw the conclusion that null hypothesis, you are rejecting the null hypothesis. You are rejecting the null hypothesis at 95% confidence. That means you are rejecting the null hypothesis at 5% level of significance or at 95% of confidence. It means that the conclusion you are drawing that, so the farmers who have adopted the IPM technology are significantly getting higher crop yield compared to non-adopters. You are 95% sure of your result. So for this, we are using this hypothesis testing procedure. With this, see, actually you might have seen. In fact, I don't know how many of you have followed the things that I've explained. I tried my best to project it in a very, very simplest form. My objective is just to reach even the scholar or the faculty who is not yet familiar with the concept of inferential statistics. So with these practical examples, now I am going to explain you about the concepts. If we just keep on explaining the conceptual things without having any practical significance, I feel that some of you may not get interest in understanding what this concept is. So keeping that in mind, so far I've taken about more than half an hour to give you about some simple point estimation example, interval estimation examples, and also some hypothesis, simple hypothesis testing examples. Now I am going to explain you about the formal things about this inferential statistics. Now let me come to this the process to draw inference. I think it is bit reverse. Many people used to explain about the concept, then they will come to example. But now I have explained you about some practical examples. Now I am coming to some some conceptual framework. See, what is this? How do we draw inference? What is the process involved in it? See, any research for that matter, particularly, of course, sometimes you may ask question, sir, all research will have invariably have hypothesis. Sometimes not necessarily. See, you can formulate hypothesis only if you have some basic information about your research, if you have some theoretical support for your research, or some other logic for that. If you don't have anything, if your research is to explore something in an exploratory kind of research, when you don't have any information about anything, sometimes you may not have any kind of hypothesis of your own. In that case, using inferential statistics may not be of use. Say, even any researcher who go for some kind of exploring some, say, this is a kind of, we in history, we find that this is the site of this kingdom. Let us go for excavation here. We can find something. Only thing you may be having in your mind that we may get something there. But you cannot say, I can find it. I can find some gold here. I can find some monuments here. You may not having that kind of hypothesis in your mind. You are simply excavating to find something. So exploring. In a explorative kind of research, sometimes you may not have hypothesis in your mind. In that kind of things, you may not have hypothesis in your mind. Okay, leave it. But most of the times, particularly in the research like in economics, in commerce, in management, in sociology, in political science, most of the research will start with some hypothesis. Okay, what is this process of drawing inference? See, normally you begin the research through formulation of some hypothesis. See, in fact, some doubt, you get some doubt, sometimes your doubt may be in the raw form. Usually, let us see, for example, this self-help groups have started to help women. Self-help groups started to help women. Oh, you get the doubt, probably this self-help group might empower the woman. This is a kind of question you get in your mind. Question in the mind that, oh, let us try that. Let us see how far these self-help groups have helped women in how far these self-help groups have helped in empowering women. So like that, normally research, in most of the cases, research begins with some kind of thinking, some kind of doubts in your mind. But you are putting it in the form of research hypothesis. So normally researchers begin the research through some hypothesis. After that, normally while designing your research, you select the sample which is representative of population. Normally, while testing any hypothesis, we want data. And also you will understand what kind of data is needed and how to collect the data. And for that, if you want to collect data from primary survey, you are going to select the sample. After, and also you will understand. So I just emphasize one thing, sample which is representative of population. So how you are going to collect sample is not important, but your sample must be scientific. That's it. I mean, your sampling method must be scientific, and you should design in such a way that the sample you are selecting must be good representative of population. That's it. It left to you. You are the master of your research. You should have logic. Yesterday only, our keynote speaker rightly mentioned, research is all about logic. Whatever you speak, you should have some scientific logical things. You must be able to depend with some scientific logic. And after that, you have to collect the data, you have to consolidate the data. This is what I just, before this, I told you about that master data sheet, In that master data sheet, you are consolidating the data, consolidated form of the data. And after that, consolidating the data in the master data sheet, You are going to calculate the appropriate descriptive statistics like mean, correlation, regression, whatever you want. In fact, you might have seen. For example, just few minutes ago, I have taken data from the cotton yield of the farmers who have adopted IPM technology and the farmers who have not adopted the IPM technology. So that is the master data. That is the data. For that, I have calculated arithmetic mean. So that arithmetic mean is descriptive statistics. It is a mean. And then sometimes you may present the data in the tabular form. So the people who have adopted this technology, they have obtained mean yield is 14 quintal. And those who have not adopted, their average yield is 11 quintal. Like that, you can put it in a tabular format. Then you have to draw. Then you have to use some inferential statistical techniques. Again, inferential statistical test. Nowadays, there are huge number of test procedures, but very, very widely used test as I have observed. If you analyze social science, if you analyze the research in social science, in my observation, most widely used inferential statistical test is chi-square particularly in psychology, sociology, in other political science. Quite often people use this chi-square test. Of course, even t-test is one such which is being widely used in social science research. And even ANOVA, F-test, single factor ANOVA, double factor ANOVA, one-way classification, two-way these are some of the tests which we are using while drawing the inference. So this is something, the way how we have to draw the inference. Let me recapitulate the concept of hypothesis testing. With this background examples and all other things, let me explain and recapitulate the concept of hypothesis testing. In fact, hypothesis testing is the process of using statistical techniques to determine the probability that a specific hypothesis is true. I told you that, no? See, yeah, I think in the subsequent paragraph, I have given some example. In fact, hypothesis testing is evaluating two mutually exclusive statements about a population to determine which statement is the best, which statement is best supported by your sample data. As I told you, normally we begin research with research hypothesis. Yeah, I've taken simple examples here. H1, always H1 indicate alternative hypothesis. H0 indicate null hypothesis. H1 research hypothesis, say I just started research stating that membership in self-help groups has enhanced the banking habit among the women. Membership in SHG, self-help groups, has enhanced the banking habit among women. Banking habit among women means, say, just visiting banks, having some savings account in the banks, depositing some amount in the banks, drawing some loan from bank, they're all banking habit. Say, empirical research you can conduct. Your hypothesis, since you observe that, becoming member in SHG, women have started visiting banks. Let us say, initially you may observe that, you get the doubt that self-help groups have improved the banking habit among women. So for that, with that, to empirically verify that thing which is there in your mind, to empirically verify that you have undertaken this research. So this is your research hypothesis. And to test this process, we have some null hypothesis. As name itself indicate, we formulate null hypothesis in such a way as to nullify it. Null hypothesis is, of course, deliberately your intention is not to nullify it. I just emphasizing it. Normally, your hypothesis, you begin your research with the research hypothesis, which later you call it as alternative hypothesis. To test it in the testing process, you are using a null hypothesis. Null hypothesis, here in this example, null hypothesis is membership in self-help groups has not enhanced the banking habit among the women. Whether woman is participating in SHG or not participating, their banking habit is one and the same. There is no much change. See, even the women who have participated in SHGs, their banking habit has not changed compared to the other group of women. So this is what the null hypothesis is. So here it is how we are, see, most of the times, even in research presentation, most of the times I find, particularly among social scientists, even while making their final PhD thesis presentation, most of the things are not much clear about the concept of alternate, their research hypothesis and their null hypothesis. So, with knowing that, of course, I am not, here in this platform, here and right now, some 57 faculties are listening to me. There may be some few who are very well versed in this. I am not targeting the people who are very well versed in this, but I find a lot of people who don't know much about it. So therefore, I am just focusing on these things. And in fact, since it is obviously it happens to be an heterogeneous group, somebody may feel that, oh, my presentation you may feel that my presentation is very simple. Oh, what is this? This capacity building is not increasing my capacity. It is just below my level. Yeah, sometimes some people may feel like that. Yeah, but my target is on majority. Yeah, here the sample data support the rejection of null hypothesis. Actually, even testing process, our entire focus is whether the data, whether this testing process is rejecting the null hypothesis or whether we have sufficient reason to reject null hypothesis or not to reject null hypothesis. Focus is only on that, rejecting null hypothesis or not rejecting null hypothesis. Many a time, so sometimes, yeah, that is true. Indirectly, you are not rejecting, you are rejecting null hypothesis means indirectly it means that you are accepting your alternative or research hypothesis, but you should not say that. While drawing inference on scientific principle, this itself is a big art. And I find a lot of people commit mistake. Oh, so therefore, since I have rejected null hypothesis, we could accept the alternative. No, don't write it. So you can draw the statement that, yeah. So suppose if your testing process rejects the null hypothesis, you can draw the inference that, yeah, this self-help groups, we could draw the inference that self-help group has enhanced the banking habit among women. You are not saying that you are accepting the alternative hypothesis. You are telling what you want to tell. What your researcher, what is the thing that you wanted to through your research, you are telling that. So in that way, you have to draw the inference. And then of course, I have told a lot of things about this already. Even while I was in earlier slide, I explained a lot of things which is already there in this slide. And in fact, research is research with the hypothesis in his mind. I already told it. It is called research hypothesis in the testing procedure. It is known as alternative hypothesis. I have told it. The membership in SHG has enhanced saving level among the women. Of course, you put it banking habit, I told. Saving level. I'm just saying, I'm putting it in different form. Saving level. Oh, earlier the amount that they saved in bank was less. Now it has increased like that. In the hypothesis testing processes, another hypothesis which is opposite to this hypothesis is formulated, and it is known as null hypothesis. Null hypothesis here in this example for this alternative hypothesis, null hypothesis is membership in SHG has not enhanced the saving level among the women. You could observe, I have highlighted with red color. Here, see, only difference here, in alternative hypothesis, I have written only yes. Here I have written as not. Except this difference, you can find almost similar. Statement are similar. Membership in SHG has enhanced the saving level among the women. Here, the membership in SHG has not enhanced the saving level among the women. So this is the difference between this null hypothesis and alternative hypothesis. So this is how, just through this, I want to convey you about the concept of this hypothesis, research hypothesis or alternative hypothesis, and also null hypothesis. So, and subsequently we shall proceed to still little further things. And see, in this testing process, let me explain you some most important things here. Chetan?
Yes, sir. Yes, sir.
Yeah, I think very interesting thing is usually when I started my presentation, there were some 30, 35, 40 participants were there.
Yes, sir.
Gradually, it moved to some 40, 50 like. Actually,
Yes,
afternoon session, usually scholars used to take rest from 2:30 to 3:30 or so.
Yes, sir.
From 3:30 onwards, more and more scholars are joining.
Okay.
Yeah. How long could I extend? I could take another 15, 20 minutes now?
Sir, you can take up to 4, sir. 4:15. 4 o'clock, 4:15.
Yeah. Since,
Yes.
of course, yeah. Now it has become 60, no problem. My intention is to I have to reach more number of scholars. That's it. Whether it is at 3:30 or 4:30, I don't know.
Okay.
Yeah. Let me explain you some important things about the most important points to be considered while selecting this test. Yeah, I told you about how to formulate hypothesis and the procedure involved in it and concept of null hypothesis, alternative hypothesis, and all that things. Most of the things are which test I have to use, how to select a test. Yeah, let me explain you some important things which you have to consider while selecting a particular test. I mean, there are many tests. They used to say Z test is there. There is T test, and within T test, whether we have to go for pair T test or independent T test. I mean, we have to go for dependent T test or independent T test, or whether I want to go for ANOVA or F test, like that. Which one you have to do? The most important thing that you have to understand here, you need to have, first important thing that you have to analyze is information about nature of population distribution from which sample is drawn. I mean to say, whether could you make some assumption about the nature of population distribution? I mean, assuming sample distribution. And again, here the question arises, what is the sampling distribution? What is the sampling distribution? It's a big question. See, while selecting I told you no, while selecting test, whether T or Z, within T, which T, and J and ANOVA. See, while selecting it, what kind of distribution we have? What is the kind of population distribution? For that, what is the sample distribution? Quite often we are using the concept of the sample distribution. Sample distribution. Say, actually, Suchitra madam is going to tell you about probability and probability theoretical distribution and all that things. Let me briefly explain about the concept of sampling distribution. Chetan, is it visible? Sampling distribution slide is visible now?
No, sir.
It is not visible?
No, sir.
Concept of sampling distribution is not visible then?
No, sir.
Hyperlink is not working. Okay. Okay.
Is it visible on your screen, sir?
For me, it was visible.
So, if it is visible, what you do is you stop the screen share. Again, you start the screen share with that thing, sir.
Yeah. I think I can do it now. Yeah.
Yes, sir.
I think now it is visible.
Now it is visible, sir.
Sampling distribution, right?
Yes, sir.
But it is not. Yeah. What is the sampling distribution? Actually, imagine drawing all possible sample size of n from a population, and for each sample, calculate a statistic. For example, the sample means. Actually, we used to draw some sample from a population. Assuming that you are drawing the samples repeatedly from the same population and calculating some sample statistics. If you put it in a frequency distribution format, that is called sampling distribution. To make it still more clear, I think probably many of you may feel, oh, what is this? Even sometimes concept itself may not easily understandable. Suppose we have a population which consists of 5 elements. I have an example here. Say, I have a population which has only 5 elements, 2, 3, 4, 5, 6. Okay. I have a population. I have 5 number of population size is 5. The 2, 3, 4, 5, 6, they indicate the values of some population value. The values of different elements of population. Here, if you take the mean for this, it is the population mean. It is the population mean. And if you take the standard deviation, population standard deviation is 1.4. You can test it. Here, you can take, say, from this population, let us take sample of 2. You can take one as 2, another one as 5. If you take 2 and 5, 2 plus 5 is 7, by 2, it is 3.5. Sample statistics is 3.5. Like that is it one sample. Sample mean. Like that, you can take large number of samples. Let me show it again. See here, you can see. See, population elements are 5. Here, the one element has the value of 2, second element has the value of 3, third element has the value of 4, and fourth element has the value of 5, and fifth element has the value of 6. And from this population, we have taken 2 samples. In first sample, we have taken 2 as first unit and 2 as second unit. Repeatedly, actually, it is not conditional. You just take 2 and putting the same slip on it. Once again, there is a probability that on both the times you may select 2. See, 2 indicate another second sample. One time you may select 2, another time it may select 3. And in 10th, you can see it's 10. One time 3 is selected, another time 6 is selected. Here in 19, one time 5 was selected, another time 5 was selected. Like that, from the same 5 population, with the 5 population, we have selected 25 different samples, and 25 different sample means 25 sample different means. If we put the sample means on this graph, we may get the frequency distribution like this. You can observe here. In first sample mean was 2. Second one, sample mean was 2.5, like that. See, this frequency distribution was like this. You could see. If we take, I mean to say, if we take random sample from a population, the sample statistics will follow the normal distribution like this. It is what I wanted to tell. It is what I wanted to tell. This is the concept of distribution, concept of theoretical distribution, sampling distribution. It is only based on this concept of sample distribution, how the sample distributions are selected. Based on these things, we are using the word sample distribution here. Yeah, with this, once again, I'm sharing my screen here. I'm coming back. Coming back in the sense I'm again sharing screen. Yeah. Yeah, I was here, right? I was explaining it. Yeah, I came back to original thing. So like this, we have to, what kind of distribution we have? We used to say parametric, non-parametric. If you have the parametric sample, we go for Z test, T test, or F test. If we could not draw any conclusion about the population sample distribution, we go for non-parametric test. Of course, Professor Mahesh is going to explain you more about parametric and non-parametric test. Here chi-square is one of the non-parametric tests. We are not using, we are not drawing any, we are not making any assumption about the nature of population distribution here. And then another thing which you have to consider is how many sample variables are there. Whether we have one variable or 2 variable. If you have 1 or 2 variable, we can go for Z test or 2 test. For example, just now we compared the cotton yield of adapters and non-adapters. Adapters group is one sample, non-adapters group is another group. These are the 2 groups of sample. Here I can go for T test. If I have 3 groups, non-adapters group, partially adapters group, and fully adapters group, 3 groups. In that case, I could not go for T. In that case, we have to go for ANOVA. So in that case, we have to go for ANOVA. If there are 3 or more than 3 such kind of sample groups, if you want to compare the mean values, we have to go for ANOVA. And again, we have to understand what kind of sample, whether we have dependent sample or independent sample. Dependent sample, see, if you are selecting sample for one group, if it is independent of selecting sample for another group, it is called independent sample. Say, here we have taken, say, adapters, IPM adapters group and IPM non-adapters, it is independent. Selecting adapters group is not depend upon the selecting sample groups from the non-adapters. They are independent altogether. The adapters are altogether different. Adapters are altogether different from the non-adapters. So this is independent sample. Suppose if we have to adapt, say like, for example, if we are using, I'm going to explain about, see, if we take the average score obtained after a training, if we take the score before training and after training, for the same group of respondent, we are taking the average, we are measuring the average performance before training and after training. So sample in one group is dependent on the sample in another group. So this is dependent sample, like that. Many times while reading statistics books, inferential statistics books, most of the beginners in research literature, oh, what is this independent sample and dependent sample? For that, to enable you to understand this concept, I'm just trying to, I'm trying giving you hint about what is dependent sample and what is independent sample. Actually, once what it happened, once actually a researcher who has submitted this almost at the verge of submitting a thesis, he has used the pair t-test in the place where he is supposed to use the independent t-test. And actually he consulted me, and that professor has consulted me, and in fact he is very good in statistics also. And in fact I learned a lot of things from that professor. And after I see many times, though knowing very well, sometimes we get confused. Even while understanding, see, simple things may become very complex sometimes. Sometimes, say, we used to say it is common sense. You know that common sense is not very common with all, like that. So this is the thing that you have to take dependent sample and independent sample, and you have to take sample size, small sample and large sample. See, small sample, if sample size is less than 30, we used to say small sample. More than 30, it is a large sample. Of course, whenever there is large sample, we could go for Z test. But in research literature, you might have seen, even in case of large sample, most of the scholars use the t-test instead of normal Z test. Because reason is, as the sampling distribution increasing, t distribution almost resembles to the normal distribution. See, t distribution resembles the normal distribution. Because of many of the good things with the t-test, people go for t-test instead of that Z-test. That is, many scholars used to ask, say, you are telling that, sir, see, whenever sample size is large, I have seen many research articles where sample size is large, but people have used the t-test. Yes, we can use, no problem, your conclusion will be the same. But of course, that is also okay. Even if you use the t-test, absolutely no problem. Conventionally, people are using that. So like that. So these are some of the important things that which you have to keep in mind while using this, while selecting the test, and also in testing. Most of the times, while drawing inference, we are using the concept called type 1 error, type 2 error in the research. So sometimes it happens. See, your decision. See, actual truth is the actual truth on the one side, reality of the things is the one side, and your decision is on the other side. See, if your decision is on par with the actual truth, your decision is right. See, a researcher who take right decision is one whose decision is inconsistent with the reality or the truth about the population. You are a best judge, and your conclusions, research conclusions, are accurate. If that is not the case, the decisions, there may be some different alternatives are possible. See, actual truth, in actually, null hypothesis may be true or null hypothesis may be false. In reality, your decision, you may reject null hypothesis or you may not reject null hypothesis. So you can observe here, if null hypothesis is true, you are not rejecting null hypothesis, your decision is correct. Correct decision. You can see this matrix. If null hypothesis is true, here you can see, And if you are not rejecting the null hypothesis, your decision is correct. If your null hypothesis is true, but you are rejected the null hypothesis, you are committing type 1 error. And if your null hypothesis is false, but if you are not rejecting null hypothesis, you are committing type 2 error. If your null hypothesis is false and rejecting null hypothesis, then also your decision is correct. So these are the possibilities. See,
Sir, we are not able to see the matrix.
Oh, sorry. Okay, why it happens like that, Chetan?
So normally it shouldn't happen like that.
I think actually I am using this hyperlink, hyperlink strategy that I use. Maybe because of that reason, it may be happening like that. Okay, I think now is it visible?
Now it is visible, sir.
Yeah, I think, yeah. Actual truth may be, null hypothesis may be true, null hypothesis may be false. Your decision, you may be rejecting null hypothesis or you may not be rejecting null hypothesis. If null hypothesis is true, if you are not rejecting null hypothesis, your decision is correct. If null hypothesis is true, but you are rejected null hypothesis, you are committing type 1 error. And if your null hypothesis is false, but you are not rejecting null hypothesis, then you are committing type 2 error. And if null hypothesis is false and rejecting, then decision is correct. So therefore, you may take right decision, or your decision may be right, or you may commit type 1 or type 2 error. These are the possibilities in the hypothesis testing process. But always you may find that, yeah, actually this here is the importance, significance of this level of significance. Most of the times, most of the scholars, I find that people are not much clear about what is the concept of this level of significance. Let me brief you about the level of significance here. Actually, you will be able to understand the level of significance if you properly understand the concept of this correct decision, type 1 and type 2 error. Actually, in hypothesis test, the level of significance, your maximum allowable probability of making type 1 error. In fact, you are indicating it by alpha. You are, most of the mature scholar used to ask, what is your alpha level? Most of the scholars, what is your alpha level? Alpha level is what is the significance level you have mentioned. It is significant at 1%. It is significant at 1% means you are testing your hypothesis at 1% probability level. What is that? Alpha level is 1%. That means there is 1% probability that you may correct. There is 1% chance that you may commit one type 1 error. I mean to say here it is that you may reject null hypothesis when actually it is true. That is called the type 1 error. You are putting 1% probability means you are testing an hypothesis at 1% probability means you are rejecting null hypothesis when actually it is true. So making such mistake is 1% only. So this is called the level of significance in the hypothesis testing procedure. Always see what is the right level of significance, whether we have to go for 1% level of significance or 5% level of, say, it is left to you. Sometimes in social science, we test the hypothesis sometimes at 1% level of significance, sometimes at 5%. Even sometimes I have seen many social science researchers who are using 10% level of significance. Nowadays, actually the scholars, particularly in the economics literature, who are writing research articles for reputed and Scopus Index and other kind of journals, people are going for probability level. They are not using this 1% or other thing. They are using probability level. They specifically mention, it is whatever probability is there, they will mention it is probability. It is significant at 0.11% like that. They are using that probability rather than going for level of putting that. They put the things as they are getting from the softwares. And by setting the level of significance at small value, you are saying that you want the probability of rejecting true null hypothesis to be as small as possible. You are putting 5%, you are putting 1% rather than 5% means you want to reduce the probability of committing type 1 error at the level, minimum possible level. That is what the level of significance means. And with this, even in testing process, with this level of significance, actually while testing, you may select 1% significance level, 5% like that. And also, whenever you are calculating sample statistics and comparing, of course, nowadays it is not a problem. Actually, even if you calculate, you can calculate some any t-test or other ANOVA, they used to give critical value and table value. They used to give at the software itself generate the result and it will give you. But if you consult the tables, it will ask you whether you want the value for one-tail test or two-tail test. What is this one-tail test or two-tail test? Actually, there comes the significance of this distribution. I have shown you that sampling distribution, sampling distributions looks like this. Say, you are calculating some sample statistic. And after calculating sample statistic, where exactly your sample statistic exists in the distribution position. If you are many scholars ask me question whether I have to go for one-tail test, two-tail test. It depends upon kind of alternative hypothesis you have. Normally, null hypothesis used to say there is no significant difference. There is no significant difference. In alternative hypothesis, if you say that, oh, there is significant difference, you are not stating whether it is greater than or less than, you are not stating. You are just stating that it is significantly different. In that case, alternative hypothesis is not directional. The actual value may be on the left side or on the right side. In that case, you have to go for two-tail test. If your alternative hypothesis, sometimes, for example, just now I mentioned, IPM technology is enhancing the yield. If your hypothesis is that IPM cotton yield among adopters of IPM is definitely greater than the farmers who have not adopted this technology, you could observe that your hypothesis, your alternative research hypothesis is unidirectional. You are stating that the yield is more among the adopters. So your alternative hypothesis is single directional. You are not stating it is not equal. You are saying that it is greater than. In that case, you have to go for one-tail test. So this is what. So still I have many other things. About that one-tail test, two-tail test. I think I hope it is 4:15. Now people started, of course. I told since 59. After another, in this 15 to 20 minutes, already 10 people have left, Chetan.
Yes,
Some 10 people have left. Let me conclude in another 2-3 minutes. After that, if you have any questions, we could have some discussion. In fact,
yes,
I have some case studies, examples also. Whenever I get some time, I will discuss with that case studies also. See, the most important thing that you have to understand in this statistical inferencing is, first thing is your sample unit must be good representative of population. That you must ensure that is the first thing. And random sampling, which give equal chance of being selected to each unit of population, is the best sample method. And in fact, if you are using non-probability sampling, you need not go for inferential statistics at all, and calculate the statistics which describe the characteristics of the sample group, and conclusion on parameter which describe the characteristics of the population. And you have to draw conclusion about the parameter and sampling distribution, and use appropriate sampling distribution to draw the conclusions. And of course, right, depending upon situation, based on the nature of the study, you could decide about your level of significance. Of course, in social science, in my experience, not an issue whether you are using at 1%, 5%, or even if you go for probability level, not an issue. Yeah, these are some of the key things that you have to keep in your mind while you are using the inferential statistics. With this, I hope I made a little, some introductory attempt for this statistical inference. In the subsequent classes, in the subsequent, maybe I may take another 1 or 2 sessions. In that sessions, I'm, depending on your need, maybe at later stage, I may explain about regression or some practical inferential statistical techniques like ANOVA, even still I have many other case studies. I will discuss with all of you. With this, if you have any questions, you are free to ask me. Thank you.
If any of the participants have any question, you can unmute yourself and ask your question to the professor. If any of the participants have any questions or comments, you can unmute yourself and speak. Anyway, sir, I have some questions, sir.
Oh, ask me, Chetan.
Sir, actually, thing is like I'm not that much familiar with this T and F and all that.
Okay.
So here, the first clarity I wanted is regarding this.
Yes.
Chi-square test is actually used for this when we actually take two qualitative variables, right? When we are taking two qualitative variables, and if we want to know the association of significance of, if you want to know the significance of association of relationship between the two qualitative variables, then we will go for chi-square test.
Yes, definitely.
Now, when we are actually, now in this backdrop, if we are using t-test,
yeah.
So t-test is only for quantitative variables, is it, sir?
Yeah, t-test actually, whether two or, t-test is for some quantitative variables. For example, just now I mentioned t-test, no? I told you about the yield of cotton obtained by the adapters and non-adapters. It is a quantitative variable, measurable, right? So measurable, we want, we get one arithmetic mean value of cotton yield for adapters and another arithmetic mean value of cotton for non-adapters to test the significance of difference. Whether this difference, I know actually adapters obtained 14 quintals, non-adapters get 14 or 11 or some nearly close to 12 quintals. Whether the difference is the real or by chance. To know it, we used to use this t-test, okay? Normally we use this, t-test is used only in case of quantitative data, no doubt. And as you rightly mentioned, chi-square test, usually it is a test of association. When we have two, for example, technology adoption and education, right? Technology adoption and education. You are classifying the education, you are classifying the samples based on education, like, illiterates, the people with primary education, people with secondary education, people with college education. You are making classification. This is one kind of classification based on, even of course, education can be made on quantitative also, but adoption, non-adoption, it is qualitative. Whether the education is having, whether the adoption of technology is significantly associated with the level of education. To know the influence of education on the adoption, we can use this test. How far this adoption is significantly associated with the level of education. I mean to say, whether adoption has anything to do with this education. Adoption of technology is having anything to do with this education. To know that kind of things, we are using this chi-square test.
So actually, when we are speaking about t-test, we are going to take only one phenomena, be it like here you actually told the production between the adopters of chemical fertilizers and non-adopters.
Right.
But the thing is, the variable is only one thing, that is the production.
Yeah.
And taking production as a variable,
right?
I am trying to analyze whether this adoption is having any difference or not. So here, basically when we are dealing with chi-square test, we are actually trying to understand the significance of association between two variables. So the two variables, how they are related, we are trying to understand. But when we are actually trying to speak about this t-test, we are going to find whether they are different or not. There is any difference or not.
Yeah, significantly different or not. Okay.
Okay. So here, so chi-square basically means whether there is relationship or not.
Yeah.
And T basically means whether they are different or not?
Yeah. And one thing, Chetan, I tell you,
Yes,
if
sir.
both the variables are quantitative,
Yeah,
if both the variables are quantitative,
yeah.
finding relationship and degree extent of relationship, you could go for that correlation analysis.
Correlation
Right,
analysis.
right.
Yeah.
You can estimate the descriptive statistics. Correlation, you can calculate the correlation coefficient, and also by using the same t-test, whether the calculated chi-square value is statistically significant or not. Even for that also you can use t-test. Okay.
Okay, sir. Yeah.
Okay, for that also you can use the t-test. And
Yes,
if
sir.
the two variables are quantitative in nature,
Yeah.
in that case, even you can go for this correlation analysis also. Okay.
Okay, sir. Yeah.
Right.
Okay,
Yeah.
sir. Now I understood this much.
Yeah.
Now the thing is here, when you took the t-test, you actually took a cross-sectional data into question. So can I use t-test in case of time series as well?
Yeah, I tell you one example.
Yes, sir. Yeah.
Even in case of time series.
Yeah.
Yeah, take the price of X shares and price of Y shares.
Yeah.
Over 12 months. Okay.
Yeah.
Over a period of 12 months. You are taking the model value of X shares and Y shares in January, February, like that. You are taking the model share price of X share and Y share. And also you can raise how much price this X share has raised. In each month, you can calculate it. And in that case also you can use the T. See, only thing is whether you can find difference in the two quantitative variables or not. Even if it is a time series data, in some context, if you want to know whether the average value of two variables which are taken over a period of time, in that case also you can use this t-test.
Okay, sir. Okay, so now I understood when we use chi-square and when we use t-test.
Yeah.
So thing is, when do we use f-test, sir?
Yeah, like for example, I told you, no. Good question. Actually, I told you adapters and we have taken adapters and non-adapters, right? IPM adapters and non-adapters, two groups. We have taken the yield of adapters and we have taken the yield of non-adapters. There are two groups. When we want to calculate this arithmetic mean value among these two groups, we can go for t-test. If we have more than two groups, like for example, non-adapters, you may create one more group, partially adapters, fully adapters. You have two group of samples. One group of sample we have fully adapted. One group of farmers we have partially adapted. Another group of farmers we have not at all adapted. You are taking average value of among these three groups. In that case, you cannot go for t-test.
Okay, sir. Yeah.
You have to go for ANOVA. In that case, you have to go for ANOVA. This is one simple example that I'm telling you. And
okay, so got it. Now the thing is, in ANOVA, is there again a rider that I have to go with only quantitative, or can I bring qualitative variable as well?
No. In case of qualitative, you cannot run ANOVA.
Okay, sir. So ANOVA is actually only for quantitative when I have more than two series of variables.
Yes, exactly.
Okay. Now the last question, sir. The last question is, you just glanced over this paired t-test and independent t-test.
Yeah.
Could you just clarify it once again, sir, with example?
Paired is independent t-test. I told you one example.
Yeah.
Actually, if time permits, I have some practical examples also. Definitely, that's that presentation. I think by this time, last time I have given that presentation. I don't know why you have followed it.
I have not been using that.
It is not just enough if you just listen and forget it. You will get perfection only when you use some tests in practical situations, right?
Yes, sir. Yeah.
See, independent. The example that I've given. See, sample, adapter sample and non-adapter sample. Selecting the sample for adapters group is independent of selecting sample for non-adapters, right?
Yes,
followed it, sample. Yeah. Followed it, Chetan. Could you follow it?
Yes, sir.
Yeah. See, let me give one more example. See, I want to analyze impact of self-help group on the savings level, right? Savings level. Could you follow me, Chetan?
Yes, sir. Yes, sir. Yeah.
how much the participants are saving, how much what is the amount of saving before becoming member and after becoming member. See, here we have taken the sample of 100 self-help group members, 100 self-help group members. From them, we have taken savings, monthly annual savings before they become members, annual savings after they become members. Okay. Here you have to go for you have to go for a paid t-test. Do you know the reason? Because sample is same. Sample is same. This is a dependent. You have two values. One is one average value, average saving value among 100 group of 100 sample group before they become member. Average value of saving of the same 100 members after they become members. So it means the sample in the second group is the same as the sample in the first group. So selection of using of the sample for second group depends on the sample which you are using for the first group. So they are dependent. So in this case, you have to go for paid t-test, Chetan.
Okay, sir. Yes,
this point.
Yeah, got it, sir. Yeah.
And I have some other examples. If I get an opportunity, I will tell you.
Give me for independent t-test, sir.
Yeah.
One example for independent t-test.
Independent, just now I mentioned,
that adopters and non-adopters,
adopters
right?
and non-adopters. See,
so they're completely unrelated with each other.
Yeah. Group of samples are independent.
Unrelated.
They are not related. Sample in one group are not related with the sample of other group. They are totally independent. In that case, you have to go for independent t-test.
Okay,
Actually, in Excel, you have this option. In Excel, if you go to the data analysis toolbar, if you select t-test, it will ask you whether you want to go for independent t-test or dependent t-test. Sometimes people may not understand.
Yes,
randomly, they go by their random selection. But that is very wrong procedure. Sometimes it leads to misinterpretation of the result, right?
Yeah, now I got clarity regarding all the three tests. Thanks.
Right, Chetan. Yeah. I think it is 4:30.
Yes, sir. So if any of your participants wants to raise any question, the participants can unmute themselves and ask the professor.
Lakshmikant, sir. I think Lakshmikant, unmute yourself. I think you are not listening to me. I mean, you are not audible. Sorry. I think I could observe that you are speaking, but I am not.
Actually, sir, I think Lakshmikant sir must raise the speaker's volume in the laptop, sir.
Yeah, Lakshmikant sir, raise your volume in the laptop or the device with which you are logged in. You are not audible, sir. Still, you are not audible. I could observe that you are speaking. There is some technical issue with Lakshmikant sir. I think. Any others want to speak? Sorry, sir, Lakshmikant sir. I'm sorry, I'm not able to hear you.
So, shall we end the session, sir?
Yeah, I think we could end now.
Fine, sir. Again, on behalf of ICSSR Capacity Building Program, as well as Department of Studies in Economics, as well as Research Scholars Forum, I would like to wholeheartedly thank Professor Rangappa sir for putting in lots of effort and vividly presenting his ideas in the PPTs in which he actually presented. We could see that sir had put lots of effort in constructing all the PPTs and all that, and despite sir's busy and hectic schedule, making time for giving such detailed presentation with relevant practical examples, we wholeheartedly thank you for your time and concern, sir.
Yeah, thank you.
And we also would like to thank you on behalf of all the participants who are fortunate to enjoy your lecture as well. Thank you very much.
And definitely we will enjoy if a participant actively participate and raise some questions. No.
Yes,
I expect a lot of questions from participants, right? Right.
Yes. Okay, sir.
From next session onwards, I request it should not be just a discussion between Chetan and the some resource person. All the participants must actively participate in the discussion, and in fact, we will be very happy if the session become more interactive. Okay. Thank you all. Thank you for your presence and thank you for your participation. Thank you all. Thank you.
Thank you, sir.
Thank you very much.
Thank you, Padmini. Thank you.
Thank you, sir. Your session really very much informative and highly technical, sir. About t-test application, z-test application, and sample size is large. That is very useful to incorporate in our further research works, sir. Thank you, sir.
Yeah, thank you. And at least such feedback. And sometimes some faculty may not followed me. Even if you have any such doubts, you may some kind of information, right? Thank you. Thank you, Padmini.
Shall I end the session, sir?
Yeah, you can, Chetan. Thank you all. Thank you.